In this video I'm going to show you how to solve a word problem which involves summarizing the data in the table. So first and the most important step of the problem solving process is to read and understand the problem. So let's go ahead and read it. So this problem has a whale-watching trip that had 40 passengers altogether. We have a total revenue, and we have some relation between the prices of full fare and reduced fare. And the question is about how many full fare passengers and how many reduced fare passengers were on the ship. So we read it, we understand it, and in step 2 usually we introduce the variable, but let's hold on to it. Let's organize the data. What do we have here? We have two types of fares. So we have full fare and we have reduced fare. And of each fare we have total number of sales, right? So we have a number, or maybe quantity is a better word. Then for each fare we have a price, and each fare generates its own revenue. The relation between the quantity, price, and the revenue is that if I want to find the revenue, I would multiply quantity by price to get the revenue. So this is like a mini formula here. Quantity times price equals revenue. Now let's fill out the table. So we have a whale-watching trip with 40 passengers on board. So 40 will be here. Price. So the total revenue collected from the tickets was $11.96. So $11.96 goes right here. Does it make sense to have a total price? No, it doesn't. So we're not even going to look for that number. Full fare passengers paid $32 each. They paid 32, and the reduced fare paid 26. So the question is how many full fare passengers were on the trip. So let X be the number of full fare passengers. So this is my X. Immediately, what do we know? Due to the relation between the quantity X and 40, we can figure out that there were 40 minus X reduced fare passengers. And because of this implied formula between the columns, we can figure out that the revenue from full fare was 32X, and the revenue from reduced fare was 26 times 40 minus X. So when we use the table to organize the data, and the types of problems that do that are easily recognizable, the key to the solution is in the complete table. If you have your table complete, then you're very close to setting up the right equation. So step 4 is to set up the right equation. Usually we utilize a relation either in the row or in the column to relate the known and unknown quantities. Here we already used the first column, so there's nothing to do there. We already used these two rows, so the only thing we haven't used that is this relation in the revenue column. So what is the relation between the revenues? The total revenue is equal to the revenue from the full fare plus the revenue from the reduced fare. And that gives us the desired equation in one variable, which we can solve. So solving is the easiest part. So again, I want to remind you that 80% of your solution should be focused on the first 4 steps. Now solving can be done by hand or by using computer. So 26 times 40 is 1040 minus 26x is equal to 1196. 32x minus 26x is 6x. 1196 minus 1040 is 6, 5, 1. So x is equal to 156 divided by 6. So x is equal to 26. However, this doesn't answer the question, because the question was about how many both reduced fare and full fare passengers were on the trip. So we also have to find the quantity 40 minus x, which is 14. So now we're ready to answer the question. There were 26 full fare, and this is when actually step 2 is useful. By now I already forgot what x was, but just by looking at step 2 I see it's the full fare passengers. So there were 26 full fare and 14 reduced fare passengers. So this is an example how to use the 6-step problem solving approach to solve a problem which requires the data to be organized in the table.